at a seminar. It was really focusing on getting ready for the Newport Bermuda race, or you want to start over, Frank?
No, it's okay.
Okay.
You're fine.
It was trying to bring new people into the Newport Bermuda race, so it was given at the Pilots Point Marina a couple months ago. It does run more than the half hour we have, so let me put up the next slide and we can make some decisions. The first part, I explain what boat speed pullers are, because that is a service that we provide. We call them performance packages. The second package that we supply through the offshore office is the race optimization package, which really shows you how to best set up your boat to do well in a specific race. I then went on to explain Newport Bermuda race scoring. They use what we call performance curve scoring, which is a little bit more complex, and that's why Newport Bermuda is the only outfit that uses it, the only race. At the same time, all the complexities have been hidden in a code in an Excel spreadsheet, and that Excel spreadsheet is provided to every competitor before the race. So even though it's got all the complexity of what arguably is the fairest way to handicap a race, the complexity is completely behind the scenes. And then the last bullet is the Newport Bermuda division screen, which we probably won't get to, but the race wanted to divide boats into two different classes, as John mentioned in an earlier meeting. And those classes or divisions could be based on how much zip a boat has. And to define zip, we used a formula that Dan, I think, created, but certainly has used, which basically takes how much sail area and length you have for a given displacement. And the more the zip factor you have, the more likely you're going to be in what's called the Gibbs Hill division of Newport Bermuda. And if you're low on the zip scale, you're going to be in St. David's. One thing that I should mention, though, is this is kind of an arbitrary screen. It's not the full story of performance, and where you draw the line certainly is arbitrary. So what we did was we created a bandwidth around that particular value of the screen. If you're in that bandwidth, a little bit higher than lower than the dividing line, you get to choose which group you want to go into. Because we can't sit here and draw a line in the sand and say, you guys are all high performance boats over there and you guys here are not. There's a full continuum. Well, let me get started. Boat speed pullers. I think this is familiar to everyone, but let me go through it briefly. You are looking at a bird's eye view looking down on a boat. There's no boat drawn here, but I've got a vector here, this arrow, meaning the wind is coming down in this direction. And you can sail any number of directions, which are represented by these arrows. So we don't have boats yet that can sail dead upwind, but you can sail at some kind of an angle, and this green line here, that arc, defines what we call the true wind angle. So if this red vector represents the boat speed, and its course, so the length of the vector is the actual magnitude of your speed, and the direction shows where you're going, then this green arc is the true wind angle to the sail, to the wind. Okay, so in developing boat speed pullers, the VPP will predict this. Now you could also do this by going out on your boat and measuring the performance of your boat. So I will explain it as if you're out there collecting data on board your boat. So if there's a constant wind, so let's just say it's 10 knots, you can head in a certain direction relative to the wind, sail for a while and take an average, and come up with this, the length or magnitude of this boat speed vector, and you just mark that off. Sail a little bit higher, and you might get this dashed blue curve here, sailing even closer to the wind, and you get this one. You can see that this one obviously is slower, because as you get too close to the wind, you're going to come down and have no boat speed at all. Moving off the wind, here's a vector for about 70 degrees off the wind, 90, somewhere in the neighborhood, 120, 150, or 135, and so on. Well, you do enough of this, and you can develop this blue curve, which shows the entire envelope of what your boat can do in this one particular wind speed. We do the same thing with the VPP, except we take measurements of the boat, and we use those to basically interpolate a table of research. There's aerodynamic research, hydrodynamic research. So these all get to be predictions. And we will provide this in a performance polar package. A couple of things worthy of note here. This dashed blue arrow is the one that gives you the best component of your speed directly upwind. So the height from this horizontal line to there is greatest there, and that would be a horizontal line. Where does it just kiss this blue curve? And that's the angle in the solution that gives you your best upwind VMG. And in fact, we have a simplified version of our performance package of the VPP Handy Guide, which just gives a table of these best upwind solutions, so you know for any given wind speed, what angle and what boat speed should your boat be achieving. And going down to the bottom, if you're trying to go downwind, it's the same argument. You're looking for that part of the curve which has the lowest point, which gives you your greatest speed downwind. Now I've chosen a pretty hot boat here, so it's sailing downwind at a fairly wide angle. Okay, here is one graph that actually is in our performance package, which is an Excel spreadsheet that gets emailed to a boat. I have a series of curves here. The first one is labeled a jib. So it's the main plus a jib, and it's this solid red curve. We can then put a symmetric spinnaker on instead of the jib, always the main, of course, and that gives this blue curve here. We have an asymmetric spinnaker, which is this green curve. If there was a centerline asym, which means an asymmetric spinnaker whose tack is confined to the centerline of the boat, that would be yet another curve. And then down at the bottom here, we have a pole jib, which means you don't have a spinnaker, but you're going wing and wing. So this is a boat called Carina, which has done very well in the last two Newport Bermuda races. And you can see basically, and this is 12 knots, what her performance profile looks like. So there are specific points of interest: your best VMG upwind, best VMG downwind. Here's the crossover between jib and spinnaker to help you decide when you need to make that sail change. You can see that the symmetric and the asymmetric are about the same. That means they're probably pretty much the same area. In fact, the symmetric probably has a little bit more area because the value of going to an asymmetric is much larger when you're going reaching like this than what this shows. So her symmetric is probably a little bit larger than her asymmetric. Okay, here's Carina. Now I've got solutions for all the wind speeds from 6 to 24 knots. All the best VMG upwind solutions are here. The downwind solutions are there. And you've got information at every wind angle. I'm throwing this boat up as a comparison, so let me toggle back and forth. And I think it's pretty obvious that the upwind solutions aren't entirely different, but the downwinds are completely different. Well, as I think all of you know, what's going on here is you have a boat that's sort of like a catamaran. It's very light, and if you give it a little bit more horsepower, a little bit more wind speed, or a better apparent wind angle, the boat really takes off. It accelerates, reaches a higher speed. Therefore, heading up a little bit and getting that more horsepower in the rig gives you huge returns in what you can do in terms of boat speed. Now, this is a particularly light boat, so it'll start planing. These are 20 to 24 knot solutions. And because it can plane with that little bit more horsepower, you want to get that horsepower. So you head up a little bit, and you go up at very fast angles, very high angles downwind. As part of the performance package, you do get a printout like this. This is every 5 degrees with the best VMG upwind and downwind. This is all for one particular wind speed. If you notice the left-hand column, the wind is 13.2 knots. Well, we don't run the VPP at 13.2, we run it at 12. But a recent addition or variation to the program is that we provide you a wind speed that you would probably see at your masthead. So if there's 12 knots of wind at our standard height above the water of 10 meters, here's a boat whose rig is a good bit higher, so using a standard vertical distribution of wind, we're saying that 12 knots at 10 meters is going to be 13.2 knots for his instruments. And we've talked to the instrument manufacturers about what's the best way to proceed, and providing the wind that they would see at their masthead units is now the default approach that I use for performance packages. There are other items of interest on here. We have true wind angle, apparent wind speed, apparent wind angle, boat speed, VMG, the heel angle of the boat, and some information on the depowering. And you can see which configuration of sails is the fastest solution at each one of those angles. I mentioned this earlier. This is a summary, which we call the VPP Handy Guide, which we also market more aggressively to the PHRF sailor. It's a reduced package. It's just a very simple bit of information. You're looking at two complete solutions. We just take some scissors and cut it in half and laminate both of them. So this is a duplicate of that. So if you just look at this one here, these are your upwind VMG solutions, 6 knots to 24 knots, where, like I said, we're using masthead instrument speed 6.6 to 26.5. He gets his boat speed, apparent wind speed, apparent wind angle, and true wind angle. And since many PHRF boats are not going to be highly instrumented, having those apparents become very important. So, a complete set for upwind and downwind. Another aspect, feature of this program is that we have pages in the spreadsheet that can be saved out as text files and then imported into the popular tactical programs. So this is an expedition file. It's very simple. I mean, you think of all the millions of calculations that went into this. It all gets distilled down into a set of numbers, and then they'll put their own curves through it. There's very good reasons for them to do that. They don't want the user on board a boat to have to key in 500 solutions. Now, if they got our performance package, yes, it could read in 500 solutions. And there are other tactical programs that do read in many more points. But they've got 7 or 8 points, whatever you would want, for each wind speed, and they'll put a nice curve through that, and that will be displayed on deck. It'll be used for optimal routing or whatever the program is set up to do. Okay, here's an example of an Occam file where they do want many more points. So they're used to dealing with VPP output, where we can give them all that data. So you can see I've got the same 6 to 24 knots, but I've got many, many more angles. Well, this all comes into a spreadsheet, and they can do whatever they want to very easily. This is just a little endorsement that we got. Newport Bermuda Race and IRC Australian Champs credit U.S. Sailing's velocity prediction programs for their success. So sailors Pete Rebovich from the U.S. and David Ellis from Australia bought our package and made very good use of it. Okay, let's move on to Newport Bermuda Race scoring. There are 2 scoring systems in use in Newport Bermuda. There's IRC, it's handicapping and scoring. IRC scoring uses a single time correction factor, TCF. It's very simple to get your corrected time, CT. It's just this TCF times your elapsed time. So we have winds from 6 to 24 knots, and the scoring program will automatically slide along a curve of those handicaps. I want to emphasize right away that there is no guy behind a curtain or whatever picking a wind speed for a race. This happens automatically. And I think we should also give credit where it's due to Alan McElhenney and whoever he may have consulted with some 20 years ago in developing this concept of performance curve scoring. I'll get into it in a little bit more detail, but the problem with PCS, as we call it, is it's very difficult for a user to know what was happening on the race course. You get a bunch of ratings and you have to put a curve through them. Well, that's hard to do in your head, virtually impossible, and it's even difficult on a piece of graph paper in real time. But putting it into that Excel spreadsheet and providing it to the Newport Bermuda race fleet means they can get something, they can run the whole fleet in about 1 second with the contemporary computer. Okay, here's an example of what this curve looks like. So we've got some data up here from 6 to 24 knots. Each one, the Newport Bermuda race handicap has a particular seconds per mile prediction for the boat. And that's the use of the boat speed polars in conjunction with what conditions we think we're going to have, which wind angles and wind speeds, and what's the probability of each one of those combinations. But you get a generic curve like this. There are 7 points. Wind speed is on the horizontal axis, boat speed on the vertical, and I just put a nice smooth curve through them. So this represents, for a given boat, the profile of the handicap for that particular boat for this particular race. Now, what really got clever, and why I think Alan McElhenney is somewhat of a genius, a great insight, is the following. If there's a fast race, there are 2 reasons why. You have lots of wind and/or there was a lot of reaching. Most rules just assume there's a lot of wind if it's a multiple handicap system. But because there's the acknowledgement you got fast to Bermuda because A, you were a lot of wind, or B, you were reaching all the way, the boat speed predictions that go into the 20 and 24 knot handicaps are reaching predictions. So if it was a fast race, we don't care what you can do upwind, downwind at 6 knots, because the likelihood is you never saw that. So the handicap that gets chosen, and I'll emphasize this was automatic, is really reaching performance. Okay, on the opposite scheme, if there was a slow race, there are 2 reasons why. There was very little wind, or there was a lot of VMG beating and running. So if we take the 6 knot handicap, it's not going to have reaching in it. It's going to have VMG upwind, downwind, or windward, leeward racing. So let me go back to that curve we had. So here again, a fast race, 20 knots. This this boat speed prediction here is really reaching boat speed. There's a little bit of everything in it that's dominated by reaching. Down to 6 to 8 knots, it's dominated by windward, leeward, and in between there's a crossover and a mix of everything. Okay, let's go to last year. It was a very fast race. The scoring automatically used the high wind handicaps, which are based on reaching speeds. So you take a boat like Carina, her reaching speed was compared with that of the TP52s and the other boats that are extremely fast off the wind. So it wasn't her VMG upwind or downwind, it wasn't light air or anything, it was simply high speed reaching. She doesn't excel at high speed reaching like they do, because they'll go blistering off down towards Bermuda. And because of that, Carina was given a chance to do well in conditions where the other boats are faster. It's not just Carina, there were a number of other heavier boats that did reasonably well in the race. So a system like this, while it may sound complex, the implementation is very simple, and it does have an automatic way of bringing a greater degree of parity to any given race. It does kind of have a contrary philosophy to the every dog has his day. But I don't think Newport Bermuda is interested in that, because they only have one race every 2 years. And how long is a dog going to wait? How many years to get his day? They'd like to have as much fairness in any given race as they can. Well, let's move on to the race optimization program. It's really answering what is the best configuration of my boat. So someone calls up the offshore office on the telephone, and we talk about their boat. This is very much a hands-on process. So the first thing we would do is review the configuration options of your boat. Typically that's, what size jib, what size of spinnaker, or what kind of spinnaker. Do I want it to be symmetric, asymmetric, on a pole, Or do I want an asymmetric fixed on center line? How big should that spinnaker be? How many crews should I carry? If I'm a top program, what bulb should I use? Well, in fact, the people that can swap out bulbs, they don't come to us. They go to their designers to work with their sail makers. They do a lot of very fancy analysis, and they'll pay a lot of money to do the very same thing. What we're trying to do is democratize the process, or bring it down to the level where everyone can afford to do this. If you can afford to pay what Bjorn and John charge to go to the Newport Bermuda race, you can afford to do this little optimization. So, we find out what options are available for the boat, and we create a fleet of those configurations. We add in some enemy boats. If you want to beat Carina or Sinn Fein or a TP-52, whoever is likely to be in your class, we will include that boat in the analysis. I calculate the polars for all the boats in the fleet. From the polars, we can tabulate handicaps specific to a given race. I'll just stick with Newport Bermuda for the sake of discussion. So we'll calculate the handicaps for Newport Bermuda for each boat in this fleet. We then race the fleet through a variety of wind scenarios. We score the races and tabulate the results. So let's back up a little bit. We're going to set up a number of wind scenarios that have nothing to do, per se, with what Newport Bermuda has chosen as their wind speed and wind angle matrix. They're making a best guess based on whatever of what will work for their race. But on any given race, you cannot expect the conditions to match what they choose. Or if we switch to the Transpac race, which has a more predictable weather pattern, they don't get the same weather pattern every year. So what I'm leading up to is that what you're really going to do is you're not working against ORR here, or IRC, or whatever it is. You're really working against the choice of handicap by the committee that runs the event, because they have to make a decision, and they are going to be wrong. I don't know how wrong they're going to be, but the further wrong they are, the more leverage you have as a competitor to take advantage of the fact that they can't predict what the weather's going to be. So the point of this is to get you set up for that. So after we score the races and tabulate the results, we get to choose the optimal configuration of the boat. Okay, well, I've already gone through this slide, really. Here's what a fleet run will look like. I've got all the handicaps. This is for a Bermuda race, so we've got handicaps for each wind speed. We come in with a particular scenario, which I'll get into in a minute. We come up with the seconds per mile. That gives an elapsed time, a corrected time, and then I can rank them, and we can find out who's the winner and who's the loser. So in this particular event, this particular race, a boat with the masthead spinnaker was the winner. So it was probably a light air downwind scenario that I used for this. Second place was only 0.07 hours behind, not a big deal. But here's one that's 1.7 hours or 2 hours behind. So you can see a configuration that not only looks good or looks bad, but by how much. So let me backtrack a little bit and talk about the scenarios we use. The first thing I do is I run them through 9 scenarios. It's 3 wind speeds and 3 wind angles. So upwind, light air. You're not going to get that in a Newport Bermuda race. You may get it somewhere. There's light air, light wind reaching, light wind downwind, and then I take the same courses and go medium and heavy. All of them are constructs you'll probably never see ideally exactly as I present it. But what this does do is it educates the guy on the other end of the phone about how his boat stacks up against variations of his boat or other boats in the different conditions. And he learns much more about his boat. Now, it's not just how fast his boat is, and this is the kind of the complex part of this. It's how fast his boat is relative to another boat versus what the rule says, versus the choice of handicap. And that's the part where sometimes I have to sit and think about it to understand what's going on. Because it's one thing to understand how the performance of a boat varies with wind speed and wind angle. It's another thing to know what the VPP is doing wind speed and wind angle, especially when it can't vary everything. And then you try to balance that out. So we really have to go through this step by step with those 9 arbitrary constructs. When we're done with that, I run the boat through a series of actual recorded wind histories for a number of races. So we can say in 2010, if you had been in kind of the slow boat class, which had the member of the race, it gave me this data. Here's which boat, which configuration looks best. So there are several scenarios, several years of recorded histories. And we have another one which was taken from the pilot charts, which is observations from commercial vessels, for that time of year and that location all the way from Newport to Bermuda or wherever to wherever. Here's what the average wind speed and wind direction is. So at the end, the guy has a pretty good idea of what configuration of his boat looks pretty good. Now, let me just finish off and say that leads us up to the really critical decision. He knows what the trade-offs are. So it's a matter of how do you want to gain your boat versus the other boats to do what? What's your goal? Well, one goal is to win the Bermuda race. And you may want to do what we call a dark horse configuration, but 9 times out of 10, it's absolutely the wrong way to set your boat up. But what it does do is if you get the right conditions you want, you're going to win the race, or you're going to be among the group of boats that will have a good chance to win the race. It's the same strategy you use in the America's Cup. If you're a low budget program, you do a middle of the road design, you're not going to win because the Larry Ellisons or the Bertarellis have a budget for research that's probably 10 times what yours is, and they're going to get that very carefully refined and optimized. So if you are a low budget program from some third world country in the America's Cup, or you're just an ordinary doctor in Connecticut with a Beneteau whatever, you may consider doing the dark horse strategy. On the other hand, if you're doing the race because you're with your family and your friends and you want to have a good time, you want the boat always to sail well, the last thing you want to do is a dark horse candidate, because you might have terrible downwind speed because you've sacrificed your large spinnaker in order to get that rating advantage, so that if it's an upwind race, you've got a huge advantage. But if you get the downwind race and with your friends, no one's having fun. Everyone's going by you. You know you don't have any chance. And what's the point of doing that? So the interesting thing for me is to start doing the psychological thing. What's the risk and what's the reward? And what is it that works for you as a sailor for this given race? Now, we are a little bit over time, and I think that's a good place to wrap it up,
Sure.
rather than get into the screen.
Yeah.
Does anyone have any questions on that or any suggestions?
Is this the first year you've rolled this out before, or not this packaging?
No, it was used pretty extensively by Sinn Féin, and I think the first year we did it would have been 2008. And then in 2010, a lot of people used the package, including Karina. And then we didn't market ourselves, and in 2012, I only did a handful. So, as Dan likes to say, none of us in the offshore office are very good at marketing. Actually, he said something more derogatory than that, but I don't remember what it is.
Does CCA embrace this?
Oh, yeah.
Oh, yeah.
Well, I gave this presentation at the BROC meeting to make that edge available to everyone. We could go back to no computers and no optimal routing, but that cat's out of the bag. So let's just try to make everyone have access to these tools. Yeah.
Can you have performance curve scoring on other rating rules besides ORR?
You have to have a rule that is sensitive to wind speed, because that's what PCS really does. It was a slide across wind speed. The genius of what Alan did was he not only made it across wind speed, he said if it's a fast race, a windy race, you're probably doing reaching. So there's a slide of course content with wind speed as well.